Supplement problem number 3. Mr. Kasberg rides his bike at 6 miles per hour to the bus station. He then rides the bus to work, averaging 30 miles per hour. If he spend 20 minutes less time on the bus than on the bike, and the distance from his house to work is 26 miles, what is the distance from his house to the bus station? Okay, so our first step is to visualize the movement of the moving object. So in this problem, we have two moving objects, the bike of Mr. Kasberg, and he rides the bus going to work. Okay, so if we visualize, so from home, he used his bike going to the bus station at a rate of 6 mile per hour. Then he ride a bus going to work at 30 miles per hour. Okay. And also the distance from his house to work, the distance from his house, his home, going to his work is 26 miles. Okay. So the distance, this is 26 miles. Okay. So here, the distance travel using his bike, we can use this as D1, and the distance traveled by the bus, we can have this D2. So therefore, our equation here, we can say that we can formulate our equation from D1 plus D2 is equal to 26 miles. Okay, so let's bring out our time rate distance box. Okay, so in our time rate distance box, we need to set up the parameters of our equation. So first, we let, okay, so we let x be the time in hours from home to bus station. Okay, so we let x be the time in hours to going to the bus station. So we have our moving object, the bike, and the second moving object is the bus. He rode bus going to work. Okay, so let's fill out the table. So our rate for our bike is 6 mile per hour, and the rate of our bus is 30 miles per hour. How about for our time? Since our subject is bike, so we let x be our time of our bike. How about for our bus? That is less he spend. Let's be clear on this. He spend less 20 minutes the time on the bus on the bike. If our x is the bike, so less than. Also, the given parameter here is in 20 minutes. So before we write our equation here, our 20 minutes, convert this first into hours. Yes, before you use it in our equation. Okay, so what will happen? That will become R. That will become R. So that will become 1/3 hour. Okay, so if we write our equation here, less, what is doing less? That is minus, yes. So therefore, our parameter here is x minus 1/3. So do not write 20. You'll be wrong. You need to convert 20 minutes to hour first, because the alignment here, this is in mile per hour, the time is in hour, and the distance is in mile, unless it's different matter. Okay, so using our formula, time times rate is equal to distance. This will become 6x, and this will become 30, the quantity of x minus 1/3, sorry, 1/3. This one is 1/3 from here. Okay, so 1/3. From our equation, finally, from here, we can formulate our equation, right? Okay, so let's write our equation. This is our d1 and this is our d2. So this is 6x plus 30, the quantity of x minus 1/3 is equal, so the total distance does not change, that is 26 miles. Okay, so doing so, solving for x simultaneously, plus we substitute x to the inside quantity, so that will become 30x minus 30 times 1/3 cancel, so that will become 10 is equal to 26. So this will become 36x, so transpose negative 10 to the other side, that will become 36. Finally, our x is 36 over 36, or equal to 1. What is the unit of our x? That is 1 hour. Okay, so since the question in the problem statement is asked the distance from house to the bus station, so we simply, the distance from house to the station, this is our D1. What is the value for our D1 here? Our D1 is equal to 6x. Okay? So finally, our D1 is equal to 6 times 1. So therefore, our distance 1 is 6 miles. Okay, so I hope our solution is clear, and I hope everyone can comprehend with our solution. Okay, let's move into our next example.